Welcome everyone to the fifth lesson in a series of videos narrating the story of the binomial theorem. In the previous lesson, we embraced the concept of the binomial coefficient and the binomial expansion for a plus b raised to the power n using the binomial coefficients generated in the arithmetic triangle. Now in this lesson, we're going to enjoy and appreciate another structure for representing the binomial coefficients of the binomial theorem. We're calling it the Stieffel's table. The proponent of this table is Michael Stiefel in Germany last 1544. Stieffel's table is related to the arithmetic triangle, and we can catch a glimpse of this in Stiefel's publication entitled Arithmetica Integra of 1544. Let's take note that a similar diagram, the arithmetic triangle, existed earlier in Chinese mathematics. However, J.L. Coolidge accounted that it was unlikely that Stiefel had direct knowledge of these Chinese works. Let us also note that Stiefel's version had a particular approximate use in the extraction of roots, showing an early link between the triangle and numerical methods. The concept of extracting roots using the binomial expansion can be explained later as we move forward and embrace European mathematics, including the development of calculus. Alright, so how do we construct the Stiefel's table or Stiefel's table? Let us construct it together. So here's a glimpse of it. Okay, and I hope you're ready to build this with me. So we have columns and we have rows. So first, we're going to write the numbers 1 to 10 vertically in the first column. It's like the indexing for the row numbers. So we say 1, 2, 3. And now step number 2. To construct the second column, we start 2 rows below the top of the first column, so basically the third row. Align with the third row. The first entry of the second column is equal to the row number it aligns with. Okay, so let's see what is the number in the third row of the first column. So it's 3. So we start here, we count row 1, row 2, so row 3. We start at row 3 for the second column, and then the number here will be the number the same as the previous column at that particular row. So that's 3. Okay. Alright, now for step 3, for subsequent entry in the column, so you add the entry directly above in the current column and the entry in the previous row of the previous column. Okay, so this is the Pascal's identity. So a particular number in the current column, you get the number, you add the number above it, okay, of the current column, and the number of the previous row of the previous column. Okay, so let me show it to you. So here, the entry, so we're gonna find the number for this cell. So we're gonna look up at the same column, so above it is 3, and the number of that previous row and then previous column is 3. So we add these two. Okay, we consider the previous row, row 3, and then we add the entries at that row 3. So 3 plus 3 is 6. And then next, for this entry here, for this cell B5, we look up the previous row. We have 4 and 6, so we add them, then we have 10. Okay, and now for this cell, what is the number for this cell? The cell B6, so we look up above the previous row. We have 5 and 10, so we add them. 5 plus 10 is 15. Okay, and so on and so forth. So 6 plus 15 is 21. 21 plus 7 is 28. 8 plus 28 is 36. And then 36 plus 9 is 45. 45 plus 10 is 55, and then we have, oh, and then for B12, previous row again, the numbers are 11, 55. We add them. 11 plus 55 is 66. Okay. And then step number 4, we repeat this procedure for all following columns. Alright, so again, for the third column, we go back to the second column, and then we go to the third entry. So 3, 6, 10, that's 10. So we start here at this row 5. Okay? And then copy 10, right, as the entry of the first entry of the third column. And we do the Pascal's identity. So look at so for cell C7, look up the previous row, and then add the numbers. 10 plus 10 is 20. And then for C7, look up at the previous row, the numbers we have 15 and 20, 35. Okay. For cell C8, look up at the previous row, and then the last two numbers are 21 and 35. We add them up, so we have 56, and so on and so forth. Let's see if it's correct. Okay. Alright, and now for the fourth column, go back again to the previous column, then add 3 steps down. Go down. Please go 3 steps down. So 10, 20, 35. So we're going to start at row 7 for the fourth columns. And then copy the third number of the previous column. That's 35. And we will do the Pascal's identity. So go up to the previous column. The last two numbers are 35 and 35. So 35, 35 is 70. Okay, and now for cell D9, go up, previous row, last two numbers, 56 and 70, add them up. That's 126. And then for cell D10, go up, previous column, add the last two numbers. That's 84 and 126, that's 210. Okay, and then for G11, go up, previous row, last two numbers 120 and 210, add them up, so we have 330. And lastly for D12, go up, previous row, last two numbers 165 and 330, add them up, we have 495. Alright, so everyone, this is now the Stifel's table. So I hope that you have built it correctly with me, and I hope everything is clear. So again, if you have some questions, then you can just replay this video and make sure that you would be able to construct this independently on your own. Alright, so now that we have the coefficients, so how we're going to use the Stifel's table to expand a binomial like a plus b raised to the 7. Okay, so let's now follow the steps. So first, draw the Stifel's table. We're done it. And then our n here is 7. So go back again to the Stifel's table and then row 7. This one. So our coefficients will be 7, 21, 35, 35. Okay? So let's see here. And so the 7th row is 7, 21, 35, 35. So these are the coefficients for the expansion of a plus b raised to the power 7. And we start with a7, b0 for the first term. And then for each subsequent term, we decrease the exponent of a by 1 and increase the exponent of b by 1. And then we're going to use the coefficients in order. 7, 21, 35, 35. And after reaching the second 35, we cascade back using 21, 7 until the last term b to the 7. Okay, I'm going to demonstrate this one now. In the 7th row, we have 7, 21, 35, 35. So we start with a to the 7th. A to the 7th, okay, plus, what's that, 7, and then decrease the exponent of a, so we have a to the 6th, and then we now have b raised to the power 1. Okay, now for the third term, what is the second coefficient? 21. So we write 21, then decrease the exponent of a, we have a to the 5th, increase the exponent of b, then we have b squared. Alright, now for the next term, what is the next coefficient? It's 35. So we say, and write 35, and then decrease the exponent of a, we have a to the 4th, increase the exponent of b, we have b cubed. Okay? And then we have another 35, right? So the next coefficient will be 35, and then decrease the exponent of a, so a cubed, increase the exponent of b, so we have b to the 4th. And then we're done using the coefficient. So we cascade down. So after 35, we go back to 21. So 21, and then a, we decrease the exponent of a, so a squared, and we have b to the 5th. And then after 21, we have 7. So we have 7, a, b, then increase the exponent of b, 5 becomes 6. And finally, the last term will be just b to the 7. Alright, so these are the coefficients, or for the expansion, a, or binomial expansion, a plus b raised to the power of 7. And we use these coefficients this way. Alright, so I'll show something incredible for 21st century skills. We have a Python calculator, so we go there, okay? Alright, so we're just calling the script. So here it is, and then we enter the value of n, for example 11, and Python will display the Stifles table, and here are the coefficients when n is 11, and then this is the expansion here. Alright, so finally, for the beauty of constructivism, learning by doing, please expand two binomials presented here by following the instructions in this slide. So again, mathematics is the art of giving the same name to different things. That's from Michael Stifel himself. So thanks for watching.